warahmatullahi wabarakatuh. Hello guys, welcome back to our channel. Okay, today we're going to learn about chapter 7, that is linear momentum. Okay, as you guys, before I go further, I would like to tell that don't worry, this topic will be simple and not complicated as chapter 4 before. Okay, now I'm gonna tell you guys what we're gonna learn in this chapter. Okay, here are the lecture outline. Yeah, I'm gonna tell you guys what we're gonna learn in this chapter. Okay, first in 7.1 is momentum and impulse. 7.2 is the conservation of momentum, and the last subtopic is elastic and inelastic collision in one-dimensional. It's great, right? So now I'm going to proceed to 7.1, that is momentum and impulse. Okay, momentum and impulse. In this subtopic, you just need to know three formula. Okay, first is momentum. The symbol is small p, and the formula is P equals to mv. M stands for mass, V stands for velocity. That is why the unit is kg/m per s. Okay, momentum can be defined as the product of mass and velocity. Okay, next is impulse. Impulse, the symbol is J equals to m bracket V minus U. The unit is Newton second. Next is impulse. Impulse, the symbol is J equals to m bracket V minus U. The unit is Newton second. Impulse can be defined as change of momentum. Okay. Impulse and impulsive force, it's quite same. The difference is impulsive force have time, so that is why impulsive force defined as the rate of change of momentum. The formula of impulsive force is F equals to m bracket V minus U as formula impulse over second time. So the unit is in Newton because it is force. Okay, so I hope you guys can remember these three simple formula, that is momentum, impulse, and impulsive force. Okay, now we're gonna do some exercise to increase our knowledge in this subtopic. Okay, here a 2 kilogram brick is moving at speed of 6 meters per second. How large a force is needed to stop the brick in a time of 7 times 10 power of negative 4 seconds? Okay, first of all, basic things that we need to do is list down all the information that the question is given. Okay, first, mass equals to 2 kg. Okay, as you, if the question gives in gram, you should change it into the SI units, that is kilogram. Okay, next is the speed. The brick is moving at speed of 6 meters per second. So the U is 6 meters per second. So and the time equals to 7 times 10 power of negative 4 seconds. So in this, based on the information, we know that it has the time, the initial speed, and the mass. So the formula that we can use is the impulsive force. Okay, let's recap. What is the formula of impulsive force? It is F equals to m V minus U per T. Okay. Furthermore, based on the question also, it they want how large a force. So force is the impulsive force. Okay, now we key into the formula. So F equals to, the mass is 2 kg, to the V is 0 because the brake will stop. Okay, so 0 minus the initial velocity is 6 over the time is 7 times 10 power negative 4 second. Okay, now we use the calculator and calculate it. Okay, 2 bracket 0 minus 6 over 7 times 10 power negative 4. Okay, now we get the force equals to negative 1.71 times 10 power of negative 4. 10 power of 4, sorry. So the answer is negative 1.71 times 10 power of 4 Newton. Okay, this is the force that needed for the brake to stop at the time of 7 times 10 power of negative 4 seconds.
Okay, as Batrisyia said before, we have 3 subtopics in this chapter. For now, I'm going to tell you more about conservation of momentum. Okay, let's find it out. Okay, conservation of momentum is about the total momentum before the collision is the same as after the collision, as long as there is no net external force. Okay, let me tell you, M1 here is the mass for the first object, and U1 is the initial velocity for the first object, and V1 is the final velocity for the first object, and it follows by M2, which is the mass of the second object. U2 is the initial velocity of the second object, and V2 is the final velocity of the second object. Okay, to understand more, let's do a question. Okay, an 8 gram of bullet is fired horizontally into a 9 kg block of wood and sticks in it. The block, which is free to move, has a velocity of 40 cm per second after impact. Find the initial velocity of the bullet. Okay, so right now, the first thing that we should do is to list all of the information given, like this. This is for the bullet, so the information that I got from this question is the mass, which is actually 8 gram, but I already converted it to kilogram because we need to use SI unit, so it is 0.08 kilogram. And U1 we still don't know, and that's the question 1. M1 the same mass, and V1 we know it is 0 because the question said that the bullet sticks in the block of wood. Okay, for the second object is block of wood. M2 is 9 kilogram, U2 is 0 because it didn't move. M2 also 9 kilogram because it's the same. Velocity 2 is 0.4 meter per second. Okay, it's actually 40 centimeter per second, but as I said before, we need to convert it to SI unit, so I already converted it. So it becomes 0.4 meter per second. Okay, the next step is we just write down the formula just like this, and we just write everything, the information that we have done here in this formula. So we want to find U1, right? So after we have pasted all the information here, we just need to find U1. Okay, this is the mathematics steps. Just convert everything, and then you got U1 equals to 3.6 over 0.008. And the final answer that we got is 450 meter per second. So this is the answer for the initial velocity of the bullet. Done.
So here's the formula of elastic collision divided into three, which is momentum, kinetic energy, and complete collision. For the momentum, the formula is m1u1 plus m2u2 equals to m1v1 plus m2v2. For the kinetic energy, 1 over 2 m1u1 squared plus m2u2 squared equals to 1 over 2 m1v1 squared plus m2v2 squared. For the complete collision is negative u2 minus u1 equals to v2 minus v1. So here's the question. A body A of mass 0.5 is moving to the right with a velocity of 0.6 meter per second towards another body B of mass 0.8 kilogram at rest. After the collision, A moves to the left with a velocity of 0.1 meter per second. Find the magnitude and direction of the velocity of B after collision. Okay. So we use the formula momentum, which is m1u1 plus m2u2 equals to m1v1 plus m2v2. So when we calculate this, we'll get 0.3 equals to negative 0.05 plus 0.8 v2. Then 0.3 plus 0.05 equals to 0.8 v2. 0.35 equals to 0.8 v2. Then v2 0.8 over 0.35. Then v2 we will get 0.4375 meter per second. The answer, we get the magnitude. How we know the direction is the answer we get either negative or positive. So the answer we get positive, then the direction is to the right.
An elastic formula have two. First, momentum m1u1 plus m2u2 equals to m1 plus m2 times v. And another one is kinetic energy. 1 over 2 times m1 u1 square plus m2 u2 square equals to 1 over 2 times m1 v1 square plus m2 v2 square plus ke kinetic loss. So to gain our knowledge, we have to do a practice. So the practice is mass of 2 kg is moving with the velocity of 4 meter per second, hitting a mass of 3 kg that is moving with velocity 6 meter per second in the opposite direction. After the collision, both mass stick together. Find the velocity for each of the mass and kinetic energy loss caused by the collision. So from that question, we know that the ball is moving in the opposite direction, and after the collision, both mass stick together. So we have to draw a picture to more understand. So the ball 1 is moving to the right direction and the ball 2 is moving to the left direction. After the collision, is stick together. So the mass for the ball 1 is 2 kg and the mass for the ball 2 is 3 kg, while the initial velocity for the ball one is 4 meter per second, and inertial velocity for ball 2 is 6 meter per second. So we have to find the velocity for each of the mass. So we have to use we have to use the formula of m1u1 plus m2u2 equals to m1 plus m2 times v. So paste all the information from the question into the formula and we calculate it, we will get the velocity equals to -2 meter per second. For the question number B is kinetic energy loss caused by the collision. So we have to use the formula of 1/2 times MAUA square plus MBUB square equals to 1/2 times MAVA2 square plus MBVB square plus KE. So we place all the information given from the question and the velocity into the formula. So we will get the kinetic loss is 60 joule.